So yeah, as already said, I'm Tom. I work with Floodtex. We're a small company based in The Hague. We started about 3 years ago in Jakarta, Indonesia. And what we do is we analyze and monitor online media for water-related information, such as information about floods. So why did we start doing this? Well, actually, what you see a lot of times with disaster management, there are systems like this. They have flood early warning systems, and these are great systems. If you, for example, want to know when floods are about to happen, these systems notify you when the water level reaches a certain threshold, and they're great at predicting floods. The only problem is, people have this information, but when the flood actually starts, they have no idea what's going on. They don't know what is going on the ground, they have no on-the-ground information. And so we thought by ourselves, can we improve this situation? Basically, you can get on-the-ground information, but you have to send out people into the area. It takes a lot of manpower, it takes a lot of time, and you will not get your information directly. So we started looking around, where can we find this information? And what we found was that actually a lot of information about floods and during floods is being shared online on social media. For example, these are some examples this week from the floods in Florida due to Hurricane Irma. So as I said, we started in Indonesia, we started in Jakarta, and what we found over there was that up to 300,000 tweets a day are being shared that have the word banjir in it. And banjir means flood in Indonesian. And these are not only the tweets that contain information such as I'm flooded, but they contain much more information. For example, about water levels, but also about rescue operations going on, about flood impact, and about the causes of floods. So there's a lot of valuable information being shared online during floods. And the great thing about this is that it's actually information that is already there. You don't have to ask for these reports. They're already shared online. So we thought by ourselves, okay, all this information is found online. You have this huge amount of data, but it's just too much for one person to handle. You cannot analyze it manually. You really need an automatic system. And therefore, we started Floodtex. And what we do is we help organizations benefit from online media content in water and development projects. We do this basically using a 3-step process. Basically, we start by collecting data from a variety of online media. We perform several analyses on this content, and the results of these analyses, we share them through our dashboards and through our API. So what sources do we use? Actually, the main source we use right now is Twitter. It's very valuable information because there's a lot of content on there. So it's very interesting, for example, for event detection. By looking at the amount of tweets for a certain location, you can really see if it rises above certain thresholds, you can detect events that way. Other sources of information we're using right now are Facebook. The downside to Facebook is it's less open, it's more private communication, and basically you can only get information from public pages and groups on Facebook. But still, these pages can contain a lot of useful information. Also, we're looking at online news and blogs. And the great thing about this is that it's really information rich. You often have these really detailed articles about floods with a lot of information about it. Downside is that it's only generated somewhat later than the other sources of data. So this data is really ideal for historic analysis of what happened in the past and not so much for real-time information. What we're just starting with is WhatsApp. And WhatsApp is really a closed system, so if you want to use that, you really have to set up a dedicated group which you will monitor for water-related information. So what do we do with this information? We analyze it. We perform several analyses. For example, we derive locations from the messages we get in. We do this based on text and matching the text in the message really to our geodatabases. We detect events by looking at the number of messages we get in about certain locations. We assess the relevance. We have machine learning techniques for this that basically group incoming messages based on similarity. Then we let people annotate batches of messages that are grouped. And that way, eventually, the system can automatically classify incoming messages. Also, we use topic-based filtering to distinguish between messages about, for example, flood impact, rescue operations, or causes of floods. Something that's really specific to flooding is that we assess the reliability of every report we get in using, first of all, elevation data. We look, is the location that is reported close to a river or below sea level, something like that. We use rainfall data to see if there was a lot of rainfall in the area. And we also use satellite data, but yeah, that's more data that is coming in only later, so that's not really for real-time validation. What we're just starting with is actual flood extent mapping using the data we get in. And for this we really need high-resolution locations and elevation data. We do this together with a research institute called Deltares, and the first test has shown that you can really use all these point locations you get in combination with elevation data to make flood extent maps of an area. Another system we're developing right now is really to analyze larger news articles. What this system does is it identifies in the text all the relevant structures. So for example, reports of damage, the time of the flood, it looks at how many people were affected, things like that. So this is really an interesting system we're developing right now to automatically derive large amounts of information from news articles. So how do we share this information? As I said, we have an online dashboard. You can find it yourselves at dashboard.floodtext.com. It shows the amount of information coming in. It shows a map where the information is coming from, and also shows pictures with that information. And what you actually see over here is that there is a flood starting to happen. This was just 2 days ago, and you see a long time absolutely nothing is coming in, and suddenly there's a peak in information coming in. So that was actually a flood starting to happen in the Philippines. We also share our information through the API. It's located at api.floodtext.com. You can just access it, and there we share the raw information, so you can use it for analyses. You can put it up in other systems, in other GIS dashboards. So as I said, there was a flood going on in the Philippines. Nice thing about that was that 2 hours later we actually got pictures in from them using our system. So this is the Red Cross in the Philippines, their operations center in Manila, and they actually use our system to look at the reports on the ground of floods and look at where the locations are of floods, what people are in need, what are they doing, what rescue operations are going on. So this was really nice information. So, yeah, we have the project in the Philippines. We work together with the Red Cross over there. And for the Philippines, we have developed this dashboard you just saw, this online dashboard. And besides displaying the locations of tweets, graphs of tweets, and the pictures with them, we also have flood scenarios in there. Together with a Water Management Research Institute, we developed flood scenarios. And basically what users of the system can do, they can match the locations of information coming in to these flood scenarios. So they can choose the most appropriate flood scenario for the information they have. And this way they can get sort of an estimate of the flood extent in the entire area. Also, we're just starting in Tanzania. And the interesting thing we're doing over there is we're looking actually at the history of floods. We're using blogs and news media for that. And we do this because when we were there, they told us we have all these meteorological forecasts coming in. Or people on the ground, for example, get a message that over the next 24 hours, 65 millimeters of rain is expected. The only thing is that these people on the ground, they don't know what will happen. Will there be a flood? What will be the effect of that flood? Will houses collapse? Will people have to be evacuated? So they can't really translate it to something they need, and therefore they cannot actually prepare for the event. And what we want to do is analyze a history of flood events, also extract the impact figures for these flood events, and match these to historic rainfall amounts. And based on this, in this analysis, we can say for future forecasts, okay, a similar rainfall amount was seen at this and this time in the past, and then this and this happened. So people get kind of an estimation of what the impact of a certain meteorological event will be. So we're also just starting with something very relevant for this task, combining social media and remote sensing information. Basically the great value there is that you can fill up the gaps in temporal resolution of remote sensing data by using this real-time online media data. But you can do actually much more with that. Recently we were contacted by people from the Jet Propulsion Laboratory at NASA. And what they do actually during floods, they are tasked with retrieving satellite images. Only they have this radar data coming in, but they have to classify it. And to classify it, they need to have points in the radar data where actually floods have occurred and where it's not flooded. So they need point data, and that is actually what we can deliver. We can deliver this point data by analyzing social media, and by using that data, you can calibrate those images much faster and get your information out there much faster. Well, basically then you have flood extent information from satellite images, but what these do not show is the local impact. And that's also where social media can complement the data from satellites. Another example, not related to flooding, but more weather related, is drought monitoring. You have a lot of instruments that monitor soil moisture. Only thing is, you don't know at what amount of soil moisture do people actually experience problems on the ground. Because in some areas are generally more dry, some areas are generally more wet. So at what point are problems experienced? Well, this is actually something you can also derive from online media. And by combining it, you can really set thresholds for your satellite data. So you can use your satellite monitoring to see, okay, in the past at this point problems occurred. So you can match the two. And this really shows that there's both historic and real-time data. Both of them are really valuable in matching information to remote sensing data. So getting back to the pictures we had at the beginning. Here you see all these amazing images. But what we're doing right now is only analyzing the text in these images. So we leave out a lot of content. We're ingesting all these pictures, but we're not actively analyzing it. And if it's English, it's more or less straightforward. But if it becomes Indonesian, for example, you need really on-the-ground knowledge to get all the information from this. So that's why pictures are such an awesome tool to communicate flood-related information. They're basically a universal language. Anyone understands it, and anyone produces it. So it's the same all around the world. If you look at online media image analysis, what will be interesting in that sense? Well, first of all, you want to filter junk out. That's the very first step. Here you see, for example, a Twitter message where the message itself, the text is quite relevant. A road is closed due to floods. However, the picture with it is of a governor, and that's not really relevant in flood response. Second step in that is you really want to distinguish between different sources of information. For example, do I have a picture of flooding? Do I have a picture of flood impact? Maybe I have pictures of flood rescue operations going on. Distinguishing between this information is very important because then you can deliver the right information to the right persons. People on the ground need information about flooding. People coordinating efforts need information about rescue. Maybe insurance companies use information about flood impact. So that's really a great tool in distinguishing between the different types of information you have. And one step further is actually deriving locations and water depths from these images. For example, by combining it to already geo-referenced images, such as the images found on Mapillary, it's sort of a Google Street View platform with open data. And by doing this, you can actually use these images to create the flood maps I showed earlier on. If you have accurate point locations, accurate water depths, you can combine it with elevation data to actually create flood extent maps. So this is a short presentation of what we've got going on at FloodX. It's very interesting also to hear your presentations later on. And all these analyses, we're actually doing them together with R&D partners of ours. So we're actually working together also with PhDs from Radboud University, for example, VU University in Amsterdam. So if you're excited about this and maybe you want to cooperate, come to me. I think it's very interesting and I think it's very nice to be here. I'm looking forward to your presentations today.